Okay, greetings math people. Today we're going to look at a little trick on how to find the formula or the nth term of a quadratic sequence. So let's go ahead and get right into it.
Specialized in science and math, original black men, busting thoughts that pierce your mental, the fierce, ripping your section. Vocal toe to toe, impeccable, splitting your back, son. Simple as addition and subtraction, black thought, the infinite relax one.
All right, so we previously did a video on quadratic sequences. We'll post a link of a video up there right now. And in that particular video, we found the formula or, the nth term of the quadratic sequence. And we use a pretty traditional way of doing so is we created an augmented matrix of a system of three equations that we found when plugging in 1, 2, and 3 respectively for n. And it wasn't the most difficult thing in the world to solve that particular system of equations, but we're going to demonstrate a quicker way of finding the formula of a quadratic sequence today. So first I'll just show you how we do it, and then I'll explain why it works that way, and then we'll do a follow-up example as well. So let's go ahead and just get into it. So I'm going to write a quadratic sequence. So I'm going to write the first 4 terms of a quadratic sequence, and for this first quadratic sequence, the terms are 12, 25, 44, and 69. And so, again, a quadratic sequence, its formula, since we call it quadratic, is of the form of an squared plus bn plus c. And so what we have to do is find the values of a, b, and c. So I'm going to show you how I'm going to do it, this new trick. So what I'll do is I'll find the difference of the terms. So from 12 to 25, it's a difference of 13. From 25 to 44, it's a difference of 19. And from 44 to 69, it's a difference of 25. Now, as we mentioned in the first video, and you can refer to that if you want to kind of know the ins and outs of a quadratic sequences, a more of an introduction. Basically, the difference between the terms is not the same for a quadratic as it is for an arithmetic, but the differences of the differences, or the second level of differences, is common. So if you look, the differences between these numbers, 13 and 19 is 6, 19 and 25 is 6. So I mean, if I wanted to find the next number, I would add 6 more than 25 to 69. So I would add 31 to 69 and get 100. That would be the fifth term of the sequence. All right, but what I want to demonstrate is when I get this second level common difference, that the value of this number is actually 2a, referring to the a that's right here. So if 2a is 6, then a must be 3. So I claim that the value of a here is 3. So we have 3n squared. Now to find b, what I'll do is I'll find the actual formula for this arithmetic sequence. So the differences of a quadratic sequence represent an arithmetic sequence. And if I find the formula of this particular sequence, it's fairly easy to find. And so the formula for this particular arithmetic sequence would be 6n plus 7. And I think you can clearly see that works. If I plug in 1 for n, I get 13. If I plug in 2 for n, I'll be 12 plus 7, I get 19, etc. Now, when I get this number, the difference of this number in the arithmetic sequence that represents the differences of the quadratic sequence, and a, the difference of those two is actually b. So b here would be 4. And if I know a and b, I can easily find c, because remember, this first number, this represents when n is 1. And if you're looking at this, when n is 1, that's just a plus b plus c. And so if a plus b is 7, then to get to 12, I'm going to need 5 more. And so the explicit formula that represents the nth term of this quadratic sequence is 3n squared plus 4n plus 5. And if you're somewhat skeptical, don't believe it really works, we can just plug in when n is 1 and see if we get 12, and plug in when n is 2 and see if we get 25, etc. So if I plug in 1 for n, I think it's easy to see you're going to get 12 because you're just going to add the coefficients 3 plus 4 plus 5. If I plug in 2 for n, 2 squared is 4, and 4 times 3 is 12, and 2 times 4 is 8, and 12 and 8 is 20, plus 5 is 25. There's matches to 25. And if I plug in 3, 3 squared is 9, 9 times 3 is 27, and 3 times 4 is 12, and 27 and 12 is 39, plus 5 is 44. So there we get to 44. So I think that's fairly clear. This is the equation or formula, not the equation, the formula that does indeed describe this particular quadratic sequence. So just to review what we did to get the values for A, B, and C, we first found the second level difference, or the difference of the differences, which in this case was 6. And we said that that value represents 2A, so we basically divided by 2 to get our A. And then we found the actual formula for the differences, which is an arithmetic sequence. And when we found that formula, the second number in that formula, we took the difference of that in A, and that gave us B. And from that, basically, we just added A and B and subtracted it from A1. The first term is called A1, and that gave us C. So that's pretty much how we do it. And so let me quickly do another example with this method, and then explain why the method actually works. All right, so let's look at another quadratic sequence. And again, we'll just do 4 terms, the first 4 terms again. So this next sequence, the terms are 17, 30, 47, 68. All right, so let's do what we do. So the difference between 17 and 30 is 13. 30 and 47 is 17. And really, there's no need for me to find any more differences. Really, the first 2 is sufficient, because I really just need this difference here, which is 4, to find A. So this is 4, and remember, this is 2A, so A is going to be 2, okay? 2n squared. Now, this is an arithmetic sequence. I know I only have 2 terms, so it's really all I need. And it has a difference of 4, so its formula is going to be 4n, and in this case, it'll be 4n plus 9. And again, you can, if you don't believe, you can just plug 1 and 2 in, you'll see you get 13 and 17 respectively. So again, this number is 9, and A was 2, and so 9 minus 2 is 7. So this is going to be 7n. And then I'll just add these two, they're 9, and subtract it from 17 and get 8. And there I've solved the sequence. All right, and this time I'm not going to prove. You can pause the video and check yourself. If you plug in 1 for n, I guarantee you'll get 17. If you plug in 2, I guarantee you'll get 30. If you plug in 3, I guarantee you'll get 47, etc. So that's the trick of finding the explicit formula, or the nth term of a quadratic sequence. So now let's investigate why this actually works. Because maybe it only works for the specially chosen sequences I use. So let's show that it'll work for any sequence of the form an squared plus bn plus c, where a, b, and c are real numbers. All right. So before I demonstrate that, so I just want to reference something when I got concrete numbers, because now everything it's not going to be concrete, it's going to be letters instead of numbers. I just want you to realize that this first number in the sequence comes from when n is 1. This second number comes when n is 2. And this third number comes when n is 3, and so on. So just keep that in mind as I roll what I'm going to roll out. Okay, let me clear the page. And just to remind you that the general form of a quadratic sequence is a n squared plus b n plus c. So what I'm going to do is I'm going to write the first 3 terms of this sequence. you know, in terms of A, B, and C. So I'm not going to plug in any numbers for A, B, and C. So this way you'll show that it'll work for any real number for A, B, and C. And so the first term is the value when n is 1. And if you look here, if I plug in 1 for n, I'm just going to get A plus B plus C. So that's the first term of the sequence. The second term is when I plug in 2 for n. So if I plug in 2 for n, it'll be A times 2 squared. That'll be 4A. It'll be B times 2. That'll be 2B. And then plus C. The third term is when I plug in 3 for n. It'll be A times 3 squared. That's 9A. B times 3. That's 3B. And again, plus C. And I'll just stop with the first 3 terms. Mainly because that's really all I need, and also I'm running out of space to write the fourth term. So let's remember the process that we utilized. We found the difference of the terms, and it wasn't common. So we're going to find these differences. And so I'll just subtract like terms. So I'll do 4A minus A, that's 3A, and 2B minus B, that's B. The C's cancel. For the second and third numbers, I'll do 9A minus 4A, that's 5A, and 3B minus 2B, that's B. All right. And the next one, if I did the fourth, the difference would have been 7A plus B. Trust me, you can pause the video and try to verify that if you would like to. Now, remember, it was the difference of the differences, which we said was 2A. And if we look right here, if I take the difference of the differences, I have 5A minus 3A. That indeed is 2A, and the B's are going to cancel. So that demonstrates why this second level difference, or the difference of the differences, that's demonstrating that that will always be 2A. The difference of the differences will always be 2A, as demonstrated here. So you remember the first thing we did is we got the difference of the differences and we divided by 2, and that's how we got our A. Now remember how we got our B. How we got our B is we found the explicit formula for the differences, which was an arithmetic sequence, and the value of the difference of the second number in that formula and A was B. So I'm going to show you. So we're going to find the formula, the explicit formula for this arithmetic sequence, where the first term is 3A plus B and the second term is 5A plus B. And so before I deal with this, I'm just going to remind you quickly the easy way I find the explicit formula for an arithmetic sequence. So let me just make up an arithmetic sequence up here real quick. So let's say the terms are 7, 10, 13, 16. So here's how you find this formula. You look at the common difference. Here you can see the common difference is 3. So 3n. And you know that this first number is the value when n is 1. So if I plug in 1 for n here, this would just give me 3. But it needs to become, when it's all said and done, it needs to become 7. So all I really do is ask myself, what do I have to do to the common difference, which is 3, to get the first number in the sequence? And that would be plus 4. And you can check it, you know, when n is 1, that's 3 plus 4, that's 7. When n is 2, that's 6 plus 4, that's 10. When n is 3, that's 9 plus 4, that's 13. I think you get the drift. So again, the way I find the explicit formula of an arithmetic sequence is I find the common difference, and I basically ask myself what I have to do to the common difference to get the first number in the sequence. Or another way of thinking of it is I take the difference of the first number in the sequence and the common difference. That's how I get this guy. All right. And remember, for the sake of this, when I get it for this arithmetic sequence, that the difference of the number that's represented here and A is going to be our B. All right, so let me go and find the explicit formula for this particular arithmetic sequence. And I'm speaking of this guy with these two terms. So again, first, the number in front of n is the common difference. Okay, the common difference for these two is 2a. Okay, so 2a. And now, again, remember what we do. We ask ourselves what we have to do to the common difference to get the first number in a sequence, or just take the difference of the first number in the sequence and the common difference. And if I take that difference, I'll do 3a minus 2a and get a. And then there will also be a b. And so again, this represents the second number, and this is 2a. There's an n there, please pardon me. This represents the second number, and voila, you see that the second number, which in this one where I use explicit numbers, was 4. You can see that is simply the sum of a and b. That is why when we have this number, we subtract a from it to find the value of b. And so that's why that works the way it works. All right, so that is the reasoning why it works. So let's do just one last example doing this particular process. So I only pre-created 2 quadratic sequences for this, so I'm just going to make up the third one for this last example. So to make it up, I'm actually going to write the explicit formula, but we'll still go by the process and see that we'll get the answer that we start with. So I want to make 4 terms of a quadratic sequence. And so the easiest way for me to do that is just to write some quadratic sequence, 5n squared plus n plus, say, 10. And then I'll determine the 4 numbers by just plugging in 1, 2, 3, and 4 for n. So I'll plug in 1 for n. I'm just going to add the coefficients. That's 16. I'll plug in 2 for n. 2 squared is 4 times 5 is 20. Plus 2 is 22. Plus 10 is 32. If I plug in 3 for n, 3 squared is 9 times 5 is 45. 45 plus 3 is 48. Plus 10 is 58. And then if I plug in 4 for n, 4 squared is 16. 16 times 5 is 80. 80 plus 4 is 84. Plus 10 is 94. All right, and so on. All right. So our quadratic sequence, the first 4 elements are 16, 32, 58, and 94. Now we already know that the explicit formula is 5n squared plus n plus 10. We already know that. But let's still go through the process and see if we get that answer and see how easy it is to get that answer. So right now we're assuming we don't know this is the answer. We're trying to figure this out, but we're checking with that particular answer. So we're going to go through the process. So the first process is to find the difference of these guys. That would be 16 from 16 to 32, 32 to 58. That would be 26. Okay, we can stop there. That's all we need. Now, if we didn't know, that's all we need if we know this is a quadratic sequence. Now, if we didn't know it's a quadratic sequence, we want to get the more differences to make sure that the second level difference was common. But we're saying going in, we already know it's a quadratic sequence. All right, so now we're going to get the difference of these two. That's 10. Remember, that's 2a. So just divide it by 2, and we get a. So a is 5. Okay, 5n squared. So far, so good. Next, we'll find a formula that describes the differences, which is the arithmetic sequence. And that formula would be 10n plus 6. So remember how we do it. We find the common difference, which is 10. And we just basically take the difference of the first number and the common difference. That's how we get to 6. Now remember, the 6 is a plus b. So we want to find b. So all we have to do is subtract a. Now remember, a is 5. So 5 minus 6 is 1. So b is 1. And remember, to find c, it's just, I know this first number is a plus b plus c. And so if a plus b is 6, then I need 10 more to get to 16. All right, and there you have it. So we're going to end right there. Hope you enjoyed this video, a nice little quick trick of finding the explicit formula of a quadratic sequence. And we will see you next time.
Specialize in science and mathing, original black men, busting thoughts that pierce your mental, the fierce, ripping your section, vocal toe-to-toe, impeccable, splitting your back, son, simple as addition and subtraction, black thought, the infinite relax one.